Alright, so the next thing we're going to talk about are reference angles. And reference angles are crucially important in trig in helping us understand why we can do some of the things we can do. Because as we've seen, a lot of times we might be dealing with angles that are bigger than 90 degrees or pi halves radians, and then it makes it harder for us to think about geometrical shapes. But with the idea of a reference angle, and specifically triangles is what I'm talking about, because that's a big part of trig. Specifically with a reference angle, it allows us to still do that. So a reference angle is the acute angle. So acute means positive and less than 90 degrees, or pi halves, that the terminal side of an angle in standard position makes with the x-axis. So if I have an angle in the first quadrant, let's call this theta, my reference angle is the same angle. So I'm going to call my reference angle this little symbol that looks kind of like a fish, and we're going to call that alpha. So if it's in the first quadrant, so Q1, theta, and alpha are the same thing. Now, this is assuming that it was already an acute angle, right? Like I could have an angle that went around the circle more than once and it's still in the first quadrant. Then theta and alpha are not the same thing. If I have an angle in the second quadrant, so let's look at what this looks like. So if this is my theta, then alpha is going to be this angle. And so in this case, we want to think about how do these two relate, okay? And so if it's in the second quadrant, quadrant 2, well, I know that halfway around the circle is 180 degrees or pi radians, and so if I subtract theta from that, that will leave me with alpha. So I know depending on if I'm in radians or degrees, 180 minus theta is going to equal alpha, or pi minus theta is going to equal alpha. If I am in the third quadrant, let's look and see what this looks like. So again, I'm just going to draw an angle in standard position in the third quadrant. So here is my theta, then alpha is this angle, right? Because it's the angle between the terminal side and the x-axis. And it's always the acute angle, so it's going to be the closest distance to the x-axis. So then, how do I come up with that alpha? Well, now, theta is bigger than 180, so if I do theta minus 180 degrees, this will equal alpha, or if I do theta minus pi, this will also equal alpha, depending on if I'm in radians or degrees. Alright, and then if we are in the fourth quadrant, let's look at how this works. So if I have some angle in the fourth quadrant, this is my theta, then here is my alpha. Now I want to point out, it almost makes it look as if alpha is a negative angle here. It is not. If we had a negative angle, then we would take the positive angle would be the reference angle, because by definition a reference angle is a positive angle. So how do I find this angle though? I know that all the way around the circle is 360 degrees or 2 pi radians. So if I subtract theta from that, I know that 360 degrees minus theta is going to equal alpha, or 2 pi radians minus theta is going to equal alpha. Now I want to point out these little calculations for how I find alpha. This isn't stuff you should memorize. This is stuff that you should understand how I'm coming up with that, so that you can find the reference angle of any angle as well. But they are not things that I would recommend memorizing. In fact, I don't memorize them as I'm doing this right here. I'm just thinking about what makes sense, how do I find that. Now for the last image here, I just wanted to show you, we're not going to, let's just pick, let's say the second quadrant, but let's say let's say theta was larger than 360 or 2 pi, right? And we can even say, let's pretend that it was negative. So if I have, let's say this is my theta, I just want to point out alpha is still this angle. Okay, so it doesn't matter how big or how small the original angle is. It doesn't matter if it's positive or negative. The reference angle is still the angle, the acute angle between the terminal side and the x-axis. Okay, so let's do a few examples of this. We want to find reference angles. So determine the reference angle of -20. So the first thing I'm going to do is actually I'm going to draw the angle in standard position. So I'm going to do a quick sketch, and I don't have to, again, this doesn't need to be perfect. I just need to know which quadrant this is in. So -20 degrees, that's pretty small, right? So here, this is my theta. All right, that right there is an angle less than 90 degrees. This is negative though, so my alpha, or my reference angle, is just going to be 20 degrees because it's going to be the same location, but it's going to be positive. How about 3 pi over 7? So 3 pi over 7, I got to think in terms of sevenths. So this is, let me do this location so we're not mixing things up. Let's see, if my initial side is here, I know that this is 7 pi over 7. This is 3.5 pi over 7. So 3 pi over 7 is in the first quadrant. If it's in the first quadrant, then the same thing, then theta and alpha are the same. So the reference angle is 3 pi over 7. 420 degrees. Let's look at that. So I know that that's going to go around the circle once. That's 360. So how much more do I have to go? Well, 360 plus 60 is 420, or you could say 420 minus 360 is 60. So I know that the terminal side is going to be here. So this whole thing is my theta. Then the alpha, and sorry I didn't draw it on this one. This is the alpha. The alpha is just this angle, which we know is 60 degrees. And then let's do the 11 pi thirds. So I know this is, negative 11 pi thirds. This is negative 3 pi thirds, negative 6 pi thirds. This would be, so if I go around, once, that's negative 6 pi thirds. If I go around twice, that would be negative 12 pi thirds, so negative 11 pi thirds is a little bit less than that. So that's going to be like right here. So this is my theta. Alpha is this angle here. And so if I think, well, twice around would have been negative 12 pi thirds. This is negative 11 pi thirds. So what's the difference between those? It would be negative pi thirds. But again, my reference angle has to be a positive number. So alpha is pi thirds. All right. I want you to try the next ones on your own. Some of these are going to be easier than others, but follow the same sort of thought process that I just did on those. Draw out the original angle and think about what is the shortest way to get to the x-axis. So I want you to try all of these. Pause the video, unpause when you're ready to check. Alright, so hopefully you got these. You will notice hopefully some patterns, right? That we start to see a lot of repetition in this. Depending on what the denominator is, there can only be so many reference angles. So, for instance, the first one here is my theta. I do apologize, my handwriting's a little sloppy, which is actually normal. So I labeled this coordinate plane, and I'm going to use this as a reference for all of these, but I know since I'm dealing in terms of denominator of 5, halfway around is 5 pi over 5, because that's pi. So half of that, or a quarter of the way around, would be 2.5 pi over 5. So I know that 3 pi fifths is past that. 3/4 of the way is 7.5 pi over 5, and all the way around, which is 2 pi, is the same as 10 pi over 5. So all I'm doing is getting common denominators. So again, back up. I know 3 pi fifths is in the second quadrant, therefore the reference angle has to be to the x-axis here. What's the remaining? Well, if this was 3 pi fifths and this is 5 pi fifths, then I'm left over with 2 pi fifths. So that's my reference angle. Moving on, I'm going to go a little bit quicker. Same sort of thought process. 4 pi fifths has to be here in the second quadrant, so I'm left over with pi fifths to get to the x-axis. 6 pi fifths. Now I move past pi, so I'm in the third quadrant, but I have pi fifths to get back to the x-axis, so that is still my reference angle, or my reference angle again, I should say. 7 pi fifths is still in the third quadrant, but now I have 2 pi fifths to get back to the reference, or to the x-axis, so that is my reference angle again. 8 pi fifths is now in the fourth quadrant, and I have 2 pi fifths to get to the x-axis, so that is my reference angle again. And then 9 pi fifths again is in the fourth quadrant, and I have pi fifths more to get to the x-axis, so that is the reference angle. So again, to repeat that thought process, you always have to think about what is the closest angle to the reference angle, or what is the closest way to get to the x-axis. Sorry, I said what is the closest angle to the reference angle. What is the closest way to get to the x-axis? That is going to be the reference angle. And in terms of radians, I just need common denominators. For the last one, so here, 25 pi ninths, I'm going around the circle at least once. That would be 18 pi over 9, because that's 2 pi. If I went another halfway around, that would be 27 pi over 9. But I'm going less than that. I'm going 25 pi over 9, so I know I'm in the second quadrant. But I was 2 pi over 9 short of going 27 pi over 9. So that's my reference angle. Just to sum that up, reference angles are crucially important because a lot of what we do in trig, whether we're thinking about it or not, we're actually using the reference angle. So it's not something you have to master right now, but it is definitely something you want to understand and be able to think about, understand the vocabulary, and think about what is the shortest way for me to get to the x-axis. That is my reference angle. Any questions? All right, still being quiet. Nice work.